Welcome again, and in this video we're going to have more details about the LED, the light emitting diode. We're going to have more details about the resistor. This is the LED. It has a long pin and it has a short pin. So those are the pins there. The long pin, as I said earlier, the long pin will always be connected to the positive side, and the short pin will always be connected to the negative side, and the negative side, that's what we call ground. And in electronics, the short form of ground is GND. So this is the circuit we will come up with. You will notice that I have drawn a certain zigzag figure or diagram. This diagram represents the resistor, and that's the next thing we're going to talk about. So I will want to name it as a resistor. Resistor. A resistor, let us take, for example, we have water or we have a car moving. So this car moving, if we want the speed to reduce and the power of the car to reduce, we will have to hold the brakes at a certain angle. If we maintain the brakes constant at that angle, that constant angle is the value of our resistor. We are resisting the movement. So what a resistor does in a circuit, and this is a circuit, we talked about circuits, it resists the flow of current. The question is, what is an electric current? An electric current is any movement of electric charge carriers, such as subatomic charge particles. So what are these subatomic charge particles? We have different subatomic charge particles, like the electrons having a negative charge. We have protons, which have positive charge. We have ions, which are just atoms that have lost or gained more or one of the electrons. Then lastly, we have holes. These are just electron deficiencies that may be brought or thought of as positive particles. And when we talk about deficiencies, we just mean they are places where an electron left. So if an electron left a place, it becomes a hole. Just like if a stone left where it was, it will create a hole. So in this small description, you are seeing current which is created as a result of electrons which are negatively charged. Therefore, if something is negatively charged, they say negative will be attracted to the positive, and like charges attract. So the negative charged electrons move to the positive end of the battery, and this makes the current to go to the opposite direction, and that's why the current moves from positive side and it goes towards where we have the load. The load is something that is going to consume the current. So you won't see the current passing that load because the current is consumed, and it only comes as a result of the movement of electric charge carriers, and for our case is electrons. You can take current as water flowing in a pipe. So when that water is it's flowing in a pipe, and we have something restricting the movement. If a lot of water flows through this pipe, it will end up blowing. Maybe this is something like a dam. The LEDs is our dam. It will end up blowing the dam. So we have to make sure that depending on the size of the dam, and this dam of ours, the LED, depending on its size, we have to make sure that we have a specific braking system which can allow the specific amount of water to get to this dam of ours. So that's why we will need a specific value or a specific size in terms of rating of a resistor that will be able to resist or block out some current, so that we don't end up blowing our light emitting diode. It's just to limit the amount of current going through our light emitting diode, and hence just making sure that our light emitting diode is safe and is not blown out. So it can always be put, you can put it on either side, it doesn't harm, because in a circuit it's just total, the summation of the resistance in that circuit. So long as we have it on either side, it's like putting brakes. You can put brakes at the front tires or at the rear tires. So having the brakes at the rear tires, it will also reduce the flow rate. So even having the resistor here, it will still reduce the flow rate of the current, and also having it here, it will still reduce the flow rate. And that's why we don't have polarity for the resistor. You can connect it on either side. Next thing, we are now going to have this circuit of ours having this. Of course, these wires will be using jumper wires. Jumper wires, we say these are jumper wires. We're going to do, in the next video, we're now going to do this circuit on a breadboard and see how it is physically. Okay.